Well, good afternoon, everyone. Thank you for the introduction. It's a pleasure to be here and to bring you this work that we have made in Health School, University of Algarve. Before I speak about the purpose, I need to do like an introduction to our context. Of course, the radiology department aims to produce images, and the images must be seen actually in a digital way. Many of them, unhappily, are not even evaluated in the radiology department. They are evaluated in regular computers, for example, in the emergency department or in other places. Sometimes I advise physicians to go to the department to look for the images in our dedicated monitors. Some of them agree that they see better, but it's difficult for them to come to the radiology department. Now I will start with the purpose. The general purpose of this research was to assess if the criteria presented by the American Association of Physics in Medicine are an effective tool to evaluate the quality parameters of diagnostic monitor. Our specific objectives were to check if a primary and secondary monitor present minimum quality parameters, compare the results from primary monitors to the results for secondary diagnostic monitors, and identify the quality control most affected parameters. We selected by convenience a sample of 42 monitors. 31 of them were primary monitors exclusively dedicated to the image evaluation, and 11 were secondary monitors normally used to post-processing the image by the radiographer. We managed to get a RaySave Xi light detector and a unit that couples with the first one called Xi, and we used the TG 18 standards of the American Association of Physics in Medicine. I just want to point another thing. We don't have medical physicists in our hospital or in any other hospital with just radiology departments. So the radiographers took the step to try to understand if the radiology monitors have quality. We tested the illuminance 15 centimeters away from the monitor, and from 2 to 10 lux are okay in the primary monitors, and from 50 to 180 lux are okay for secondary monitors. We evaluated geometric distortion with a ruler, and the difference in the squares of this image should not be higher than 2% for primary monitors or 5% for secondary monitors. We evaluated the luminance uniformity, and the luminance in each corner at the center should be 18% and 10% of maximum. Measurements should not be different between each image, more than 30%. About the luminous response and contrast, we should look for half moons inside the squares. We should look for the constant number of vertical lines, and we should measure the luminance in each of the central squares presented here. I just have 3, but it's 16. About the reflection, the ambient light with the monitors turned off should not be higher than 2/3 of the minimum monitor luminance, and we should manage to observe the lines in this image with room light and no light. About resolution, we should look for these central images all around this image in the monitor, and it's accepted between 0, that this is 0, this one's very well seen, and for diagnostic monitors, and between 0 and 6 for secondary monitors. We looked for noise, for artifacts or defective pixels by evaluating dots in each monitor region. In the primary monitors, all should be seen, but the minor target. And the secondary, just the 2 bigger targets should be seen. About the internal reflection, usually when a glass is covering the monitor to protect it, we should check the low contrast images both in the black square and in the center of the white circle. And in this center, we have this image here and here the same. We should look in the primary monitors that are the better ones, at least 3. And in the secondary, we should look at least one of these small circumferences here. And we also have anatomical patterns to evaluate a thorax, a knee, and 2 breasts. And to evaluate it, we have a checklist to put it's okay or it's not okay. We made a sum of all conformities and non-conformities. We made an average, and we made a standard deviation. These are not very different values, not as big as we thought it would be. We saw that some parameters are 100% conform, which we were amazed with it, and some of them are not that good, mainly the illuminance and the internal reflection. So, from the criteria assessed, the luminance, uniformity and contrast and the diffuse reflection scored 90% and 93% of conformity. These were the best criteria in our sample. The internal reflection and the illuminance were the lowest scores, presenting 14% and 33% of conformity, respectively. And also the percentage of conformity was higher in the primary monitors, despite there were no significant difference between primary and secondary diagnostic monitors. In conclusion, our group that studied these questions, despite the American Association of Physical, are used worldwide as a quality control tool. We find some difficulties, like the conformity is considered equivalent in monitors that are near the limit and others that are not so close to the limit. And many evaluations are qualitative instead of quantitative. And in the qualitative, we had some difficulty to score it, but probably because we are not experienced enough in monitoring the monitor's quality. Thank you for your attention, and it's all.